Okay, so in this video we're talking about solving linear equations. So what's an equation? Well, in the previous video we talked about an expression is something without equals. So now here an equation is two expressions that have the same value. So two or more expressions with the same values, with the same solution set. Solution set. So for instance, here's an equation, 2 plus 3 equals 5. So both expressions, 2 plus 3 is an expression and 5 is an expression. They both have the same value, the same solution set, okay? So what's a linear equation? Well, a linear equation is just something that has its graph as a line. You might think of that first. But it's something of this format, y equals mx plus b. And here, m and b are just constants, okay? M and b are constants. So what's the solution of an equation? Well, a solution of an equation is something that satisfies both expressions, okay? So a number or numbers, so numbers that satisfy both expressions. Sometimes I'm going to call this as making a true statement on both sides. So for instance, up here we have a true statement. 2 plus 3 is 5. That's true. We know that for a fact. Right? And when are two equations equivalent? Well, when they have the same solution sets. Okay? Two equations are equivalent when they have the same solution sets. When they have the same solution sets. Okay? Now, here we have lots of properties, okay? Properties of equality, addition property, subtraction property, multiplication property, and division property. But you know what? Let's simplify all this. Essentially, it just means what you do to one side, you have to do to the other. So I'm going to put that at the top. That's super important, okay? Because otherwise, if you don't do that, if you don't do the same thing on both sides, you're not going to have an equation anymore. Your seesaw is not going to be in balance. Instead, it's going to be something like this. So, if I add by 2 on one side, then I have to add by 2 on the other side. If I subtract by 3 on one side, I have to subtract by 3 on the other side. If I multiply by 1/2 on one side, I have to multiply by 1/2 on the other. If I divide by -1 on one side, I have to divide by -1 on the other. I got to maintain that balance. I got to maintain my seesaw. I got to maintain equality, okay? So, how do these properties help us solve equations? Well, it maintains the balance. Maintains the balance. And we're going to call that maintains balance or maintains equality. To use the math word, okay? Equality just means balance. Okay? So we want to solve this. Now, a lot of you are going to be able to do this without my help. This is Algebra 1, pre-algebra type thing, but let's just go through it. So first step, subtract 9 from both sides, so 15 minus 9. 15 minus 9 is 6. I have 3/7 x equals 6. Okay? So now I have a fraction. Now you can divide by 3/7 or multiply by the reciprocal. I'm going to multiply by the reciprocal. I suggest you do the same. So remember, what you do on one side, you do to the other. So multiply both sides by the reciprocal of this fraction. So the reciprocal is 7/3. Some people call it reciprocal flip. I like to use the math language, so I'm going to use reciprocal. So times 7/3 times 7/3. Okay, now what happens here is, hey, these two fractions cancel out. The x just falls down, so x is equal to 6 times 7/3. Okay, if you type that in your calculator, we're going to have 14. Now, don't just circle or square 14, okay? It's x equals 14. If you just put 14, I'm like, 14 what? Okay, where does 14 belong? You need to tell me that 14 belongs with the x. Okay? Let's go on. Let's try this one. Now, we got variables on both sides of the equation in this problem. Don't panic. All we're going to do is get our constants on one side and get our variables on the opposite side. That's like when the two people are fighting, okay? You want to try to break them up. So here we got two gangs of people, the variables and the constants. We want to split them up, so that's what we need to do first. I typically like to get my constants on the right-hand side and my variables on the left-hand side, so that's what I'm going to do. But if you do something different, as long as we end up with the same answer, I don't care. Do what you need to do, okay? So I want to get my variables on the left-hand side, so I'm going to subtract 7n minus 7n. Cancel out, so I have 5n minus 7n is negative 2n. And then I want to get my constants on the right, so minus 11, minus 11. Cancel out. So I have negative 2n is equal to negative 9 minus 11, which is negative 20. And now I need to get n by itself, so I'm going to do that by dividing by negative 2. Cancel out, so n is equal to positive 10. Because negative negative makes it positive. Again, n is equal to 10, so that must be part of my answer. Okay. Now you can check yourself. Everywhere you see an n in the original problem, plug in 10. And you should get a true statement on both sides. Okay? We'll leave that to you though if you want to do that. Okay, and then something a little bit more complicated. Again, this is the Algebra 1 problem, but this is probably about as far as it went in Algebra 1. So, we got distributive property. Anytime you see distributive property, you need to take care of that first. So I'm going to do that. So distributive property just says the number on the outside. It's multiplied by everything on the inside. Taking it one piece at a time. It's very important. Take it one piece at a time. So 4 times 3x is 12x. 4 times negative 5 is negative 20. I'm done on this side, so I'm going to put my equals. Okay? Take care of distributive property over here. Again, don't forget this negative. Okay, so I have negative 2 times negative x is positive 2x. Negative 2 times 8 is negative 16. Minus 6x just comes down for the right. Now I'm going to simplify, so you always want to look on either side of the equation and simplify as much as possible first before you start moving things around. So I'm going to simplify over here on the right first. So I have 2x minus 6x, which is negative 4x. Minus 16 just keeps coming down. So we have 12x minus 20. Now let's look at very similar to the problem we just completed. We had variables on both sides and constants on both sides. Remember, we want to get our variables on one side, constants on the opposite side. So I'm going to get constants on the right, variables on the left. Okay, so to bring my variable to the left, I need to add 4x. Cancel out, so I have 16x. Now, I want to get my constants on the right. So plus 20, plus 20. These cancel out. So I have 20 plus negative 16, which is going to be 4. Okay, well from here it's incredibly simple. We just divide by 16 on both sides. So x is equal to 4 over 16. However, if we want to do this perfectly, we should simplify our fractions anytime possible if we can. We can in this case, so x is equal to 1/4. Now, this number is technically correct, but it's not the best answer. Okay, the best answer is always simplified. Okay. Now here we have some fractions. Oh no, we got fractions. A lot of people don't like fractions. I don't understand it because it's really easy to get rid of those fractions. All we're going to do is multiply by a common denominator. So I'm going to look all the way across and multiply by a common denominator. The easiest thing to do is just to multiply the denominators together. So to find my common denominator, so to find my common denominator, I'm going to say 3 times 4 times 6. Okay, 3 times 4 times 6. Well, that's 12 times 6. Might need to use a calculator to get that. That's 72. Now, is that the smallest common denominator? No. In fact, you might see, hey, the lowest common denominator, or the LCD, is equal to 12. I want to use the LCD, but here's what it is, okay? Essentially what we're doing is we're going to multiply by a common denominator. You can use the lowest one or not the lowest one, but eventually the fractions are going to cancel out. So, I want to use the lowest common denominator, so I'm going to multiply both sides of my equation by 12. Okay, so 12 times 1/3 is 4. X just comes along for the ride. 12 times 1/4 is 3. 12 times x is just 12x. And then negative 6 times 12 is negative 2. Now we don't have any fraction, and it's a lot nicer looking problem. So we can go ahead and solve this now. We have variables on both sides, again, constants on both sides. So we know what to do from here. Okay, so variables on the left-hand side. So I'm going to subtract 12x. Cancel out. So we have negative 8x minus 3 just to get constants on both sides. Now I know I'm going a little bit quicker with this problem because we've done it several times now, so just try to keep up as best as you can. So negative 5. Okay, so now I need to get x by itself divided by negative 8. Cancel out, so x is equal to 5/8. Now, this fraction cannot be reduced any, so don't turn it into a decimal. Do not turn it into a decimal. The reason for that is because a lot of times when you use a decimal, it's an approximation. Nowhere in this problem does it say round. When you use a decimal, you're rounding typically. So just leave it as a fraction. Get used to that. Also, don't use mixed numbers. Don't use mixed numbers. So for example, if you have 3 divided by 2, don't rewrite that as 1 1/2. Do not do that. Yes, it's true, but typically you're not going to see problems written like this at this level and beyond. You're going to see improper fractions. This is what you want, improper fractions. So this is good, and this is bad. Okay? This is kind of, honestly, babyish, okay? Don't do that. Don't do that. And that's it for this video. Thank you very much.